Okay, let's get started. Um, so as you know, final is tomorrow 7 to 10. It depends on the two sessions times, but I believe it's two of them are tomorrow. So, but anyway, so final is breaking into the three components. The first one is the midterm one redemption, and the second part is the midterm two redemption. And the third part is any new materials starting from the second midterm to right now. So because you have already learned, because it's relatively fresh, right? From the midterm two to the week 10, I think week 7 to week 10. So this final review will majority focus on the first two part of the midterm one and midterm two, because it's been a while ago. And those questions will flash back in the final exam. So yeah, I will I will put more time on the first two parts. So let's get started. So please download this PDF at Piazzas or in the email that I send out. There's a link. You could just click on the link and the PDF. You could directly download the PDF. So the first part is the Java abstraction. So the abstraction means that there's an abstract class and interface of the Java classes. So there are three type of classes that Java has. The first one is concrete class, which has an implementation for all of its method, and they cannot have any unimplemented method. And it can also extend an abstract class or implement an interface, as long as it implements all of the method. So concrete class is a class that have everything being completed and is concrete. So another thing is it is a complete class and it can be instantiated. So in contrast, contrasted with concrete class in abstract class is a restricted class that cannot be used to create objects. And then it's like a recipe for creating children objects. So abstract class has an abstract method. Some abstract method, maybe more than one or none. So the abstract method can be only to use in an abstract class, and it does not have a body. The body is provided by the subclasses. So so let's do several true and false questions here. So there are 5 true and false. So give me 1 second. Yeah, take about 3 minutes and click in the polls. Okay, I'm about to end the poll. Okay. So let me share the results. So for the first question, we see that an abstract class have both abstract and regular method. So 79% of you said true. So the correct answer of this is indeed true. So abstract class can have a abstract method and both regular method. Yeah. And then the abstract method can has no method bodies, and regular method has method body. And abstract class can have a mixture of those two methods. So the second question is kind of a little bit tricky. The second question is an interface can have both abstract and regular method. So an interface is a special type of abstract class. So an interface can only have abstract method, but not regular method. It cannot have a method body. So an interface contains only abstract method. So the second question is false. So the third question is you can instantiate an abstract class object. So the abstract class object cannot be abstract class cannot you cannot instantiate an object from an abstract classes. You must instantiate an object through a concrete class. So this one is also false. So the fourth question is an abstract class can extend a concrete class. So yes, an abstract class can extend a concrete class. And then the fifth question is a concrete class can have abstract method. So the fifth one is false. An abstract concrete class is not allowed to have any abstract method. So each and every method in the concrete class must be implemented. Any question regarding those five?
I got a quick questions.
Go ahead.
For number 4, can also abstract class also extend like another abstract class or an interface?
Yeah, it could extend another abstract class or interface.
So essentially, it can extend everything or implement everything, right?
So yes, as long as you implement everything. If you implement, if you extend abstract class or interface.
Okay, thank you.
You're welcome. Okay. So let's have a little bit wind back to the midterm one questions. So the question is about a code reading. So I'm pretty sure after midterm 1 and midterm 2, you did a lot of code on paper. So let's do that again here, because you are likely to do some of the like question in the finals. So there's two classes. The first one is the interface DSC that define two abstract classes. And then the second abstract class is the abstract class lower div and implements DSC. So how many methods should a class DSC30 implements and what are they? And yeah, and I will create a poll. Yeah, think about it 2 minutes, I think, yeah, it's pretty enough. Okay, I'm going to end the poll in 5 seconds. Yeah, okay. So I see a lot of varying answers, but the correct answer is 3. So DSC30 must implement 3 methods at minimum to make it able to compilable. So let's see. So DSC, first of all, is an interface that you could think of it as a recipe or contract. Anything that implements that interface must complete that contract, right? So by saying abstract class DSC lower div implement DSC, I kind of make a promise that in this classes I must implement 2 methods. First method is add student. The second method is remove students. So that's 2. But in this abstract class, remember, in interface, we cannot have a concrete, we cannot have like a method, right? We can only have an abstract method. We cannot have a normal method. So, but in abstract class, we could have both of them. We could have concrete method. We could have abstract method also. So in this concrete class called DSC lower div, so first of all, it implements one method that called remove students. So it finished one of the requirements from here. So right now, this is implemented. Remove student, the function of remove student is correctly implemented, has some function bodies. And then it will add 2 more abstract methods that need to be fulfilled. So in general, the first one need to be implemented is add student. Second method is update requirements. Third method need to be implemented is add grade distribution. So so the answer of this question is 3 methods. Any questions?
Yeah, Scott, I had a question. So basically, if an abstract class implements an interface, it doesn't have to implement the methods in the interface. It can keep them abstract, right?
Yes. So abstract class allows abstract method. So if an abstract class implement an interface, It essentially just add another abstract class. It's add another abstract method under the abstract class.
Oh, okay. Okay, that makes sense. Thank you.
But in the concrete class, it does not allow any abstract classes. So yeah, in the concrete class DSC30, you need to implement those three methods. So Tom asked a question in the chat: why is the method as student not in DSC lower div? So this is a way that we save some spaces to write our contract, because let me erase this. So DSC, first of all, DSC is an interface. Interface is a collection of abstract classes. And then DSC lower div implements this interface. Because this interface is saying that, okay, I signed this contract. I need to complete the two abstract method, add student and remove student. But in DSC lower div, it is still an abstract classes. So it allows the abstract method, it allows abstract method to exist in the abstract classes. Nevertheless, it does not allow abstract classes to exist in the DSC30, which is a concrete class. So yeah, does that answer your question, Tom? Okay. So Troy asked a question in the chat: how many classes or interface we could use for concrete class, abstract class, or interface? How many classes or interface we could use? I'm not sure that I understand your question. You mean how many classes, implements, or extends? You could implement a lot, as long as there is no duplicate method. So a class can implement a lot of interface and a lot of abstract classes. You could think of it in that way. You could sign the contract of you could sign multiple contracts as long as you fulfill those requirements.
I got a quick question.
Uh-huh.
So like if it implements two interface, but two interface have same method, what will happen?
So two interface will have the same method, essentially.
Yeah.
I'm not sure whether I know the answer for that, but I would take a guess.
Okay.
Because you're trying to do the, I think in abstract class is fine. It is the same method signature anyway. So you just need to complete it in the concrete class. But I don't think that's the case for the abstract class though. So for the concrete method, it does not allow you have a duplicate method. So there's confusions between duplicate method, right?
Yeah. Okay.
Yeah.
Thank you.
So someone asked a question. We don't have to explicitly implement because it is already abstract, basically. Could you clarify your question a little bit? We don't have to explicitly implement what? Which method? So add student need to be explicitly implemented in the DSC30 concrete class because it's still an impending method to be completed. So yeah, so in the abstract class, it could be kept as a signature, not implemented. But in concrete class, you have to implement it. So for DSC lower div, we do not have to implement the remove students, right? DSC lower div. Yes, so abstract class allow the abstract method to exist. Someone asked, can we allow class to extend one abstract class and one concrete class? I'm not sure. I think it could, as long as there isn't duplicate method. Yeah, because
Wait, Scott, really quickly, I thought that like, well, I guess, can one class extend multiple classes? I thought like the whole point was that like the advantage of interfaces is that like classes, you can only extend one, but interfaces you can extend multiple. So like, can you extend one abstract class and a concrete class, like making it two, or I thought it was just one? Does that make sense?
yeah, I might need to dig into doing some example to like test it out. I'm not so sure about that question.
Okay, it's
Sorry,
good.
I don't have a immediate answer for that, but I could Google.
Thank you so much, really.
Oh, I think, yeah, I'm sorry. Java does not support multiple inheritance. So you cannot extend two or more classes in a single class, but you could stack it like what we did in the DSC, like here. So you could do DSC lower div, implement DSC, and then DSC30 extend DSC. So Java. So Java does not support multiple inheritance, means that you cannot extend. It means that you cannot extend multiple classes, but you could do in this like chains, like the interface DSC that DSC lower D implements that interface, and then a concrete class that extends this abstract class. Okay, let's move on. We have a lot of stuff. So through the PAs, you might already realize that there's a lot of keywords in Java that defines the property of variables or methods. So Java keywords, in this section, we will review about final, statics, and public and private. So a real quick recap, a final keyword, as the word of meaning that is final, means that the value cannot be modified. So essentially a constant value. So this is also means that you must initialize a final variable. So we will see that later on as in examples. So if a final variable is a reference, that means that the variable cannot be rebounced to reference to another object. But in internal state of the object pointed that by that reference variable can be changed. This might be a little bit difficult to understand during the for the words, but we will see an example later on. So the static keyword. So in Java, mainly used for memory management. So the static keyword in Java is used to share the same variable or method of a given class. So the keyword here is the share. So the static keyword of if a variable is being assigned to a static variable, it's the same variable that is shared within a given class. So the user can apply static keyword with the variables, method, block, or nested classes. The static keyword belongs to the class then an instance of the class. So the static keyword is used for a constant variable or a method that is be the same for every instance of a class. So it's like repeating the sentence of this is being shared by the whole method or class. And then the third one and fourth one is the public and private. So public is a Java keyword that declares a member of access to be public. So public member are visible to other classes. This means that any other classes can access the public field over method. And contrasted in public keyword, a private keyword is an access modifier that only making an variable that only accessible within the declared class. So we have another 3 true and false question. Think about it, maybe 2 minutes, and I will launch the poll. Okay, I will end the poll in 5 seconds. All right. So the first question is, one could create a final variable without initialization. And there's a example that final int GPA. So that is not allowed. So this is false. So according to the definitions of the final variable, when you create a final variable, you must initialize it. So the correct way to create a final variable of GPA is final int GPA equals to maybe 4.0. Oh, not 0.04. It's a little bit weird to make your GPA as a final variable. Maybe after your graduation, your GPA won't change. And it's weird to make it as an integer, but anyway. So second question is, one could change the immediate content, the reference pointer value of the final variable after initialization. So this is also false. So the basic definition of the final variable is that you cannot change the immediate content. So you cannot change the GPA after I initialize it as a number 4. And if that's a pointer, you cannot change that too. So for the third question, so one could change the referred content of the final variables in code is, so the first line code here, first of all, I initialize a new integer array with size 5, and I assign it to ARR. And in this line, ARR is 0. I changed the first index, index 0 into 10. I assign 10 to the index 0 of the ARR. So this won't cause an error because I'm not changing the immediate content. I'm not changing the R itself. So I'm not changing the pointer. I'm just changing the content of the R, which is allowed. But if I do ARR equals to another new integer array with size 10, which is we usually do as a doubling the length, it is not allowed because ARR is a final variable and we cannot change the pointer to this integer array. Any question of true and false question?
So in this case, if let's say that R had something in the array, like I don't know, like it was like new int 5 and it had like 1, 2, 3, 4, 5 or something like that, right? And then we tried to change R 0 to 10. Would that change anything, or would that still be not changing like R fundamentally?
So let me draw a little diagram here to better illustrate the issues. So ARR is a variable, is a final variable.
Okay.
And that's a pointer, right? That's pointer that points toward an array with size 5. So it is a pointer. So pointer in Java is like a random, like I don't know, something like that. As long as you did not change this value, you are fine because the value here and here is ARR, the first index, zero index, and this is ARR 1. So that is not the immediate content. That is the array. So it is, if you are changing the value of the content of the array, you're not changing the array itself. You're not changing the pointer. You're changing the content. So it's allowed.
Okay, that makes sense.
So just to make sure we don't have to specify the data type before ARR. Oh, you have to. I think I have a typo here. Yeah, you need to do int. Yeah, sorry, this is a typo. Nice catch. Thank you. Any other questions?
I have a question.
Mm-hmm.
Is there any method or is there any way to define an array where you can't change the content within the array, or no?
So there might be, but I don't have a like absolute answer. I think so. The array itself, it itself as a fixed method. So the thing within the array is changeable. So you cannot like fix it as a final array.
Right. Okay, that makes sense. Thank you.
Yeah. Next question. Any other questions? Okay. So this is a multiple choice question. So encapsulation can be achieved by which of the below keywords? 1, 2, 3, 4. Yeah, you could just click in ABCD with 1, 2, 3, 4. Okay, I will close the poll in 5 seconds. All right, so 67% of you said B. So the concept of encapsulation is that you encapsulate or protect something inside inner class. So the private variable allows you to restrict access of a specific variable, right? So the private variable is only accessible within the same class. So the idea of restricting the access of specific variables, and then usually the approach is we set in specific like sensitive info as a private to a specific class, and then we create a getter or a getter and setter method for that specific variables. So the encapsulation is achieved by the keyword private. So B is the answer. Any questions?
Hi, I had a question. Can you just quickly explain again what encapsulation means exactly?
So encapsulation is it's a fancy word of saying that you're restricting some access of some specific variables. So it's just a fancy word to protect specific variable from accessing from the outside.
Thank you very much.
A quick question.
Mm-hmm.
So if inner classes is one of the option, it could also be an answer, right?
Pardon?
Also, if inner classes is one of the option, it can also be the answer.
Yeah, sure.
Okay.
Okay.
Oh, wait, Scott,
Mm-hmm.
can you repeat what you said about getters and setters?
Okay, so the first of all, encapsulation is the idea that I restrict some access to some specific variable from the outside classes, right? For example, put yourself in a shoe of a bank account. Bank has a sensitive info as your password and your balance. So those are sensitive info that you don't want other classes just like, okay, you dot balance to get out, right? Because that's unsafe. So encapsulation or the private variable help restrict the outer class to get it. But usually what we do is we create a setter method or a getter method from the same class. For example, in a bank account, you set a get balance, and within the get balance, you have several options in the input parameters, right? You could assert that, okay, do you have the correct password? Are you the owner of the account? And you could like make those if statements to filter out the unwanted access to your information. And then if the condition all satisfied, okay, I could give you this information. So that's the purpose of the setter and getter method.
Hey, can I ask you to just like do like a little quick sample code? Just like, it's like literally like 5 lines or something like that. If it's a bit much, I get it.
Yeah, I don't think I could do that. I have a lot of things to do. But the
I get
overall
it.
idea is setter and getter method. It's,
Okay.
You could think of it as like a band-aid to help outer classes to get the private method of a specific class.
Okay.
Yeah. So this is kind of long, and in the exam, I'm 95% sure you will encounter a question about static, and as a code questions, and it's definitely not this questions. So let's do a practice together. So what is the output of this main method? So pay attention to the type of the variable, and then I will launch a poll. Sorry. Yeah, 3 minutes. I will close the poll in 5 seconds. Okay, 55% of you choose C, and we'll see. So let's trace it out together to see what's the output of this main method. So first of all, we have two numbers. The first number is first variable is called num1, and it's assigned value to 6. And it's not a static variable, but num2 is a static variable. So it means that static variable means that the variable is shared with all the classes within these classes. So okay, so this line and this line is using a constructor to initialize two new instance of a static demo, S1 and S2, because there's no modifier of the accessibility of the num1 and num2. So they're all public. So S1.num1 equals to, so right, so currently S1 and S2 and num1 num2. So during the initializations, the S1, S2, the num1 of S1, S2 are both 6. And num2 are both 10. So next line, S1 num1 equals to 15. So we erase the 6 and replace it with 15. So during the exam, pay attention to what type of variable that specific variable is. So num1 is not a static variable, so it belongs to S1. It does not belong. It does not share within the class. And then the second one, S1 num2 equals to 17. So num2 is the static variable, which means that it is being shared between S1 and S2. So this line change the num2s, the num2 of both S1 and S2, and make it now the variable now is being saved as 17. So by the same token, S2, the num1 being saved to 22. So this have been changed to 22. And the last line of S2 num2 equals to 28. So num2 is a static variable, and it changed S1 and S2 num2. So it's 28 and 28. So the print statement is printing out S1 num1 and S2 num2 and S1 num2. So it's printing out in this order. So the correct answer is 15, 20, sorry. In this way, it's 28 and 22 and 28. So the correct answer is C. Any questions?
Yeah, so just to clarify, a static variable, wherever it's changed, regardless of in which class it's modified, that is the modified value that remains for all other instances of any other class.
Yes, so you are modifying the static variable, and this variable is shared within the class, right? So this line, S2 num2 28, override the previous S1 num2.
Right, so static, so a change in a static variable in one instance will also change it in all other instances within that class.
Yes, so that is the meaning of shared instance variable.
All
So they're
right, thank you so
shared.
much.
Yeah.
Okay, I had a question also about, okay, so I know that what's it called? We can't access like regular, like, well, instance variables like by themselves inside of like a static like method and stuff without making it an object, right?
Could you repeat your
Yeah. So I guess like, okay, so let's say in this problem, if we took out the initialization of S1 and S2 and just try to work with num1 and num2, that wouldn't work because what's it called? We're trying to access like a non-static variable without creating an object, right?
Yeah, so you cannot access a non-static variable in a static context. So you'll get an error saying, I think the wording is exactly the same as the you cannot access the non-static variable in a static context.
Oh,
I understand, but no.
Noel?
Could you mute? Someone's background is kind of noisy.
Damn.
Yeah,
any other questions? Does that answer your questions?
Yeah. So it's just basically we need to make S1 and S2. We need to create them like as objects, right?
Yes.
Okay, got it. That's good. Thank you.
Any other questions? Okay. I don't want to do this. I will post the answer of this later on. It's the same stuff, but with if statement. So yeah. So just remember that num2 is shared within the static demo class. So anything, so change. Oh, actually, yeah, let's do this. This is kind of, yeah, let's do this. I changed my mind. Okay, let's do it in 2 minutes. Okay, you don't have to write your reasoning, just make a choice. I will close the poll in 5 seconds. Okay, so let's do the same thing. Keep track of the variable of S1 as S2. This is a pretty good strategy when you are in the exam to lay down those the boxes that I wrote for the previous sections. So like here, so we start from the main method, right? With the main method initialized to variable, that is S1 and S2, and each S1 S2 has a num1 and num2, and this is final. Oh, sorry, static. So so this line, let's get to it. This line assign the num1 to 9 and num2 to 10. So this is 9 and 10. So if num2 is less than 30, so it's 10. So this is 10 is less than 30, right? So this num2 equals to num2. So this is 10 and this is no. And because num2 is static, so it's shared. So I directly write 10 under the S2. And then this line, num1 equals to num1. So this is a little bit tricky. So num1 is already defined within this scope, right? Num1 is 9 right now. So you're saving 9 here and to the already defined num1. So you did not change. So this line did not change the global the instance variable of num1. It's doing, so essentially it's doing nothing. So num1 is always 3. Any question to
I
that?
got a quick question.
Yeah, that's a tricky part. Yeah, go ahead.
So if you add this in front of num1, is also don't change it.
So if you add this dot num1, it changes, right? The reason why this line does not have any effect is that num1 is already defined within this like lower scope, which is already 9.
Okay.
Yeah. So if you do this dot num1, you're explicitly telling that, okay, I'm trying to change the instant variable. I'm not going to save it to a local variable. So Java is like, if I change this variable name to another name, for example, I change it to num, and then I do num1 equals to num, that will work because num1 is not defined within the smaller scope, and it will automatically detect it that, okay, you're trying to change the instance variable. Okay, with that, so the num1 is already 3. So let's erase all those. And then the second line, and then we define it 22. So 12 and 22. So num2 right now is 22. Is 22 less than 30? Yes. So we change the num2, which is static variable, into 22. And num1 is still 3. We did not change it. So the correct answer is D. It's 3, 22, 3, and 22. D. Any questions?
So whenever we don't use the keyword this in a constructor or any given function in an object, Java will go to the parameters first, or like the existing variables in the scope, and then if not, it will go try to find the instant variables. Is that correct?
Yes. So let me actually visualize this. So this is a constructor, right? The constructor is a scope, and the public class, outside class, is let me change another color. This is another scope, right? And then first of all, it will try to find num1 within the smaller scope, because that's the rules. I start from the nearest and then I step outside. So I first search the num1 within the purple scope, which is the constructor scope, and I found it. So I don't have to look upward. And then if I change the num1 to something else with not to something else, for example num, then the Java won't find num1 under this smaller scope. It only will find num1 in the outer scope. So we will change the instance variable. And if you want to like make it work properly, you could add this, which is force the Java to look at the outer scope to ignore the inner scope. Does that make sense?
Yes, thank you.
Yeah. Okay, I say we take a break of 10 minutes. I need to take a drink. Drink some water. Yeah, we'll be back in 6/16. Nice number. Yeah. Feel free to do whatever, 10 minutes. Enjoy your life. Okay, let's get started. So, hi everyone. Let's talk about exceptions. So, exception handling in Java is one of the effective means to handle runtime error that is regular flow of the application can be preserved. So Java exception handling is a mechanism that handle the runtime errors such as like class not found exception, illegal argument exception, and index out of bound exceptions, etc. So I'm pretty sure you have already see a lot of exceptions during your PAs. So let's just dive into the two types of the exceptions. So there's many two types of exceptions. The first one is built-in exceptions. Built exception is divided into check and uncheck exceptions. So the check exception means that the also called compile time exception because this exception are checked at compile time by the compilers. And in contrast, the unchecked exception is like a runtime error, a runtime exceptions. It's not compile time exceptions. So this the compiler will not check those exceptions at the compile time. So in other words, if a program throws an unchecked exceptions, even if we did not handle or declare it, the program will not give a compilation error. So pay attention. I said that this is a compilation error. So during compilation, it won't have any error, but we are not sure whether during the execution time we might have unchecked exceptions. So we have two true and false questions, and I will launch the poll and clicking. Give me 1 second. Okay, 1 minute. Okay, the first question is saying that if a program throws an unchecked exceptions, so first of all, is unchecked exceptions. Even if we did not handle it or declare it, the program will now give a compilation error. So this is exactly the same as the description of unchecked exceptions. Because it's unchecked during the compilation time, it won't give a compilation error. So this is true. And the second part is this: if some code within the method throw the check exceptions, then the method must either handle the exception or it must specify the exception using the throws keyword in the method header. So this is true. This is also true because the check exception is during the compilation time. So you must explicitly tell the Java compilers or tell the Java how I should handle this case of exceptions. So yeah, any questions?
Yeah, I had a question. Okay, so basically, for checked exceptions, I had thought that the only way to handle checked exceptions was try and catch, but is that not true?
So you could so try and catch is the handling it, right?
Mhm.
So this is the first way, handle the exception. And the second way is to throw keyword in the method header. So you could specify, okay, this method throw this check exceptions.
Okay.
Yeah, those are
then-
two ways. Yeah, go ahead.
What's it called? Can you define for me like the difference between like I understand that there's like two running time. There's like compile time and then there's running time, right?
Mhm.
So like when we say that a code compiles, but then we say that the code wouldn't run. Like, what does that mean? Like for it to compile, like, does that make sense?
Yeah. So for example, here's your Java code, right?
Okay.
Here's your Java code. DSC, whatever. And then you need to feed in this into a Java compiler to compile it into another binaries or universals that is considered like 0, 1, 0, and is into a file that computer can recognize. And then you execute it. So there's a 2 steps, right? For Java, this programming language. So you develop it here. You compile here. And you execute here. So compiler, so compile error is whether you could generate a DSC.class file. So during week 1, we demonstrate that DSC.java is a Java file, right? And then in the terminal, you put in Java, C for compile, and then DSC Java. So this command won't run your code, but it will compile your code. And then you compile code, and after that, you will generate a file that called DSC.class. So this is the compilation, and this is the execution. Does that make sense?
So yeah, so basically the compiler turns it into something the computer can understand, but then the execution, I guess, like, what would that look like? Does that make sense?
So during the execution, the Java is executing the universal file, the binary file that only that works for our CPUs. And it's executing line by lines, right? I'm not sure. I'm not sure that I understand what do you mean by how does that work?
Like it's just it's good for now. I'll keep going off of this, and if I have a question, I'll just ask afterwards.
Yeah, sure. Yeah. So okay. So what is the difference between throws and throws in Java? So throw and throws, there are 2 different keywords, right? Throws is got defined within the method header. So throw defines a method that might throw a specific kind of exceptions. But throw without the S is when you actually want to elicit new exceptions. So I will give 2 examples here. The throws in real sense is usually it happens like public void test and then throw exceptions, and that exists in the method headers. But throw is usually in throw new maybe illegal argument exceptions. So those are the 2 key differences between those 2 keywords. Any questions about this?
Sorry, so which one is for the check and uncheck exception?
You mean throw and throws?
Yeah, I think the throws is gonna be for unchecked exception and throw is for the checked one, right? Or sorry, the other way. Throw is for the checked exception and throw is for unchecked.
So throw and throws are all for the exceptions. It does not care whether exception is checked or unchecked, because you could throw new check exception here. So it just those two keywords serve different purposes in the Java. So the throw keyword is used to throw an exception for any method, right? This line of code can happen in any method within a method body. But throws defines that this method will throws a specific exceptions. So throw and throws does not have to do anything with the whether exception is checked or not. Does that make sense?
I got a quick
So,
question.
sorry, go ahead.
Okay, so like when you declare throws in method header, but like inside your method you have a check exception and you didn't handle it, it still didn't compile, right?
So if you have a check exceptions under, so you either declare. So first way is to declare with this, right?
Yeah,
And the second way is to use try catch.
yeah.
Yeah.
So I mean, if you have throws in method header, but inside the method you got a check exception, but you didn't handle it, it still didn't compile, right?
It will compile, I think. So as long as you it will compile as long as you did not call this method. If you call this method, then you need to handle it.
Okay.
I think I remember there's a better way to explain it. It's like when you say throws exception, it's like sometimes you don't know how to handle. So you leave it for the person that use the function to deal with it.
Yeah.
When you have throw without s, that's the time that you handle the exception. Is that right?
Yeah, correct. So throws, so that's the purposes of the throws, right? This give users ability to handle it. And then if you use try catch, you're essentially predefining how you are going to handle with that specific exceptions. So you don't have that flexibility here. Yeah, okay. So JUnit test for exceptions. We do a lot of exceptions in our PAs, and we always wanted to test our create test case for exceptions. And JUnit is one of the unit testing skills that we were going to test you during the final exams. So given that those this method get scores and that accept a string of student, and we want to catch that if the student is equals to null, it throws a new illegal argument exceptions. So I don't think we have enough time to let you do it, but I would just share two ways that you could check the exception in the JUnit file. So the first way, that is the most apparent way, is using try catch block. So in code, it is try and then get the score. I will use IAE as a shorthand. So in this way, you are testing whether this line of code is actually throwing that exception or not. So usually we will have a fail here and saying a message that the expected exception is not thrown. And during the catch, you don't have because we want to test that it throws an illegal argument exception, right? Usually we put nothing here because that is as expected. And the second way of doing things is we add a tag. So it's first test. So it's expected equals to IAE dot class. And then your so this way it's also allow you to test whether the get score equals to null that throw this illegal argument exceptions. So any question regarding those two ways to test exceptions?
It's asking for 3. Is there like another way?
So
Or should we, like be creative?
so there I might word this question a little bit off. I think in order to create 3 distinct JUnit tests, you must not like only test exceptions. So yeah, you need to test whether it's returned correctly. So
Thank you.
yeah, so with that in mind, so we need to abide to the conventions of the assert, right? Usually assert equals. So the first argument is expected. And the second argument is actual. So the sequence should not be flipped. So you should always put the expected value in the first parameter and the actual parameter in the second parameters. That is the convention of assert equals of the JUnit file. Oh, I have a duplicate questions. Sorry. Okay. Any questions for the first part? It's taking longer than I thought.
Just a real quick question. Do we need to use assert equals, or can we just say assert, blah, 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 equals, blah, 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 blah?
So you both works, but the conventional way of using JUnit is using assert equals, or you could use
Okay.
assert true.
Okay.
Yeah. And there's only one statement here. But in Python, usually you just use assert and assert true. Assert directly without any equals.
I have quick questions.
Mhm.
For the track catch method, do we need to print out something to show there is an exception we catch?
During an exam, I don't think so. Otherwise, only if the question explicitly told you to do so.
Okay, thank you.
Yeah. Okay, the second part, the funny part. So sorting algorithm. So that's the from the midterm 1 to midterm 2 part. I type a lot of words in this PDF. I'm not going to repeat those. You could just the purpose of like typing a lot of things like knowledge or like description down here is for your benefit to later on when you want to review it. So yeah, let's just go to the question directly. So this example is I went over in the discussion sessions, and I think it's good to like just redo it again. And then the question is: imagine you're in Geyser library, you are presented with an unsorted book, and your goal is to sort them by their title according to alphabetical order. So this is a sorting question, and you have a element to sort. So which sorting algorithm you need to use to minimize the sort time complexity? So the first situation is the n is extra large and you cannot sort it by yourself. You sort the book for 2 hours and you ask for your coworker to replace you in sorting the book. You won't tell your coworker your current progress since you want them to suffer another 2 hours, but you will tell them which sort algorithm you used. So for this question, during the finals or during the midterms, we will present you with like a situations that led you to think about which sorting algorithm you should use. So in this case, let's analyze the situation together. So we want to sort the n books, which is relatively large, and then we sort it for 2 hours. So you have already made some progress, and then you want another coworker to help you to sort it. So here the answer is the insertion sort. So the benefit of insertion sort is it's quick in nearly sorted array. So insertion sort has the best time complexity of linear time. So so we try our best to not use the selection sort, because selection sort always has the best and the worst time complexity of n squared, which is a quadratic time. So given that, so the insertion sort has this nice property that allows us to have intermediate, nearly sorted array that our coworker will continue to work on where we left off. Yeah, is there questions?
Yeah. Are we assuming here that your coworker has to use the same sorting as you?
Yeah, sure.
Okay, because otherwise, wouldn't it be best to do quick sort and then your coworker uses insertion sort after you pass it off to them?
It's relatively hard for a human to do quick sort, right? Because you're doing a lot of comparisons.
Okay, makes sense. Thank you.
Wait, would the question then be better sorted, be better worded to say like you tell them which sort they should use?
Yeah, sure.
Okay.
So when we do questions like this on the exam, do we could take into consideration that like, oh, this or like this is human doing it, so comparisons, we need to minimize the number of comparisons we should do.
I'm not sure. I haven't seen at the exam yet. I'm not sure whether we have a question like this, but yeah, you could always argue.
I was also wondering, n is extra large, and then I have sorted the books for 2 hours, and then we want the coworker to do, or like, I guess like the coworker is gonna sort for like another 2 hours. So it's just, we're just sorting n, like half of n's like content. So it's not like nearly sorted out, is it?
So depends on what sorting algorithm you have already used. So if you're using insertion sort, it's the first part of the array is in sorted order, right?
Right.
And then your coworker can pick it up from the sorted order and continue to elongate that sorted list. So the cases here, the point I want to make here is that insertion sort has the best time complexity of linear time. And is the way is we contrast it with selection sort, because if you use selection sort, everyone should look at the smallest element first, even though the array is already sorted.
Gotcha. Okay. Thank you.
You're welcome. Okay, I will skip the second question. It's kind of weird. So stable and unstable sorting algorithm. What is the difference between stable and unstable sorting algorithm? So it's a like definitions. So stable sorting algorithm means that after sorting, relative order is preserved. And unstable is the relative order does not preserve. Yeah, it's
Wait,
uh-huh.
Scott, what do you mean by relative order is preserved?
So for example, I have an array that is 1, 1, 1, 2, 3, 4.
Okay.
And then let's not use this. It's 1, 3, 1, 2, 4, 1. So I have 3 ones here, right? The first one is I mark it as blue. The second one I mark it as purple. The third one I mark it as orange. So in the sorted order, I wanted the sorted array is 1, 1, 1, 2, 3, 4, right?
Okay.
So if I mean by this sorting algorithm is stable, the purple this one should be at top, and the purple one should in the middle, and the orange one should be in the bottom. So if you line up this one, the relative order is preserved. There is no crossovers.
Okay. So what would be something that isn't relative order is not preserved?
Yeah, so if we ended up, the second one is the orange one, and the last one is the purple one. There is a crossover of the orange line, right? I put element here and put element here. There's a cross here. So this is unstable.
Oh, well, okay, so how did you pick blue, purple, and orange? Like, how did you choose those?
It's arbitrary for the
Mhm.
beginnings of the orders, right? So
Oh,
you imagine this in sorting algorithm, you are rearrange the things, right?
right.
If there's a duplicate, there's multiple ways that you could arrange this one in multiple ways.
Oh, okay, so you're choosing the duplicates.
Yeah.
Okay, so basically you're saying that like, so then are there sorting algorithms that keep like the blue, purple, and orange in the same?
Yeah. There is sorting. There is several sorting algorithm as stable and several are not.
Okay, I get it. Thank you so much.
Yeah. Okay. Any other questions? Ella asked, can you go over 1.1.2? Is it? Oh, I haven't go over that yet. I don't think that's necessary here. Yeah, the solution of this is merge sort. It means that you have a lot of space, but this question is not rigorous enough, so I don't want to touch that. So okay, let's do some multiple choice. So this question asks, suppose we have a linear time algorithm that finds the median of an unsorted array. Now consider a quicksort implementation where we first find the median using evolve algorithm, then use median as a pivot. What would be the worst case time complexity of this modified quicksort? And ABCD. Where's my cursor? Okay, click in the polls think about it for 1 minute. Okay, I will close the poll in 5 seconds. Okay, so let's analyze it together. So the worst case time complexity of this modified quicksort. So this quicksort, assuming that we have a linear time algorithm that find the median of the unsorted array. So the quicksort first is move the pivot into sorted positions. So it's better to remind about the definition of median. The median is another way of saying is the 50 percentile of the unsorted array. So if I use a median as a pivot, for example, here is my array. If I use a median, that will eventually the sorted position of the median should be ideally the half of the array. And then I'm splitting it. I'm splitting the quicksort in this ideal positions. So the worst case complexity of this modified quicksort is the best case complexity of the quicksort, which is the n log n. So you might think the A might also correct. So A is a correct answer if you take into the account of the finding the median. So if you're taking a time complexity account into the finding the median, that take linear times, and then doing a quicksort that takes logarithmic times. So it's n log n.
I got a quick question. But if every time you pick a median that is the smallest or the largest number in the array, it should be n squared, right?
So the median won't be the largest and smallest element in the array, right? The median,
But you cannot guarantee.
Yeah, go ahead.
I saw your median is like the middle position, the number in it, but like the number can be the smallest or the largest. Yeah,
So,
if in this case your 1 is in the middle, when you're picking the pivot, it should be the smallest.
So the median, so median is not, so the median is the in the center in the sorted order, right?
Yeah.
So in unsorted order, I could find that median within here, find median here. And then I move that median to the sorted order. So in this case, the median is 1, 2, 3, 5, 0, 1. Okay, 0, 1. So these two are the middle elements, right?
Yeah.
And then if I fix 2 as the median, it serves well, right? Does that make sense?
Yeah, but like if your 2 is instead of 2, you get 0 in that position, you will get a smallest number in the array.
Yeah, but if I could do 10, I swap 10 and 2 here, the median of this array is still 2. The median is here. So the median should be at the center if the array is already sorted.
Sorry. I think he's asking. I think he thinks that when we do the first loop, we're gonna pick the median index instead of value. But the real thing is when we run it, we're gonna find the real median value, and we move it into the correct position.
Yeah,
that's how it makes a difference.
Yeah, thank you, Colin. Yeah, does that answer your question?
Yeah, makes sense. Thank you.
Yeah, so it's the median value, but it's not the median positions. So so A and D are both correct. So A is correct if you take into the account of finding the median, and D is the correct. D is also correct if you don't, if you just don't think about finding the median. And then so okay, let me remove this. So the best case of quicksort is n log n, right? Any question about the best case of the quicksort? So everyone agrees that the best case time complexity of quicksort is n log n. And then when do we achieve the best case of the quicksort? So
When we have, oh, go ahead. Oh,
yeah,
sorry.
go ahead.
You were asking a question. I was gonna say when we have like the ideal median,
Yeah.
right? Yeah.
So when we split the array into exactly 1/2 of the subarray, we have the best case, right? So the question here is that, okay, we already have a magic that tells you the median of unsorted array. This question is essentially asking you what is the best time complexity of the modified quicksort. Because in this case, the worst time complexity is the best time complexity of quicksort. Because we are forcing our sorting algorithm to directly choose the median as the pivot. So the worst time complexity of the quicksort is the let me write it down. Is n squared. Is you are choosing the pivot that is the always the largest of or the smallest element in the array. And because we are choosing the median right now, we are avoiding this worst case as far as possible. So we are just aiming at the best case.
Just to make sure, are we finding the median for each quicksort run or just like the starting?
No, run each. So the question said we first find a median and then use median as pivot. This is like a divide and conquer procedures.
So finding the median and actually doing quicksort, they're like different operations, which is why it's n log n.
Yes.
Okay.
This question is kind of tricky. It's I got it from the interview question, so. So A is also correct if you take into the account of finding a median. So D is correct if we only consider the quicksort itself. So D is the best case of the modified quicksort. Yeah, this question is so the question asks us, I think the question is kind of vague. So I think A and D is all valid answer. When does the discussion go to? I don't know. I have too many things to go over, and I'm pretty slow right now. I might just ended up posting the answers, and yeah. Okay. This question, real quick. Which of the following sorting algorithm is the typical implementation give the best performance when applied on an array which is sorted or almost sorted? Maximum 1 or 2 elements are misplaced. Real quick, just type in the chat, please. Yeah, the insertion sort. It's the same reason I in the library situation, it just without that context. So insertion sort has this best time complexity of linear time. So yeah, whenever you want to like have an intermediate state or almost sorted or sorted things, you should use insertion sort. Okay. This one, actually, I will launch the poll. So consider a situation where swap operation is very costly. So it's very expensive to swap. Which of the following sorting algorithms should be preferred? The number of swap operations are minimized. A, B, C, and D. Okay, so so in the case that the swap operation is very costly, we want to minimize the swap, right? Heap sort, first of all, I need to heapify the array, correct? So heapify array, that takes a lot of swappings into the array that, so I need to heapify my array. That is a lot of swapping. And that is the first step. And if you want to use the heap sort, so heap sort, essentially you are having a priority queue, and then you are popping out the largest element one by one. So every single time you pop out, you need to maintaining the heap structure, right? So the procedure of maintaining the heap structure is a lot of swapping. You're swapping with the parents node, with the children's node, a lot with the levels. The heap sort is costly in this case. Any questions? So heap sort. So for the selection sort, we're selecting our element from 1 to selection sort. We are selecting the elements, the largest element first, and then the second largest element first, second, right? So we are actually just doing n times of swap, because we are only need to swap n elements together. Because although the comparison takes a lot of time, we do a lot of comparisons, but the actual swapping is only linear or n, because the procedure of the selection sort is first I find the largest element or the smallest element, and then I swap it the largest element with the sorted array. So swapping in the selection sort is minimized. So the correct answer here is number 2, or B. So insertion sort is not correct, because insertion sort, you're inserting element from, for example, you're inserting element you're inserting this bar to here, and then you're repeating this process over and over again. So the procedure of the insertion means that you need to swap a lot. And the merge sort is notoriously, you need to swap a lot, because you're essentially merging. The process of merging is swapping the element a lot of times from the base case, and I swap here, and then to this case, and then I combine it to a larger array. So this procedure is taking elements, swapping it by a lot of times. So any question for 1.5?
For insertion sort, what's it called? Wouldn't that also be maximum n switches or no?
Insertion sort.
Yeah, like because in selection sort, I get the like, because we're constantly like swapping with the smallest number in the array. So like there can only be max n smallest numbers, right? But what's it called for insertion sort? We're also kind of like just, well, we're checking like basically like step by step of like, okay, I'm checking if the next one is bigger than it. So wouldn't there be like a maximum amount of next ones that are n? If that, you know what I mean?
Yeah, but you're swapping things, right? You're the procedure of comparing with the next element in place is actually you need to swap them.
Right, and then okay, so then when I swap with the next one, I basically have to keep swapping with the ones that are before it if it's
Yeah.
bigger or small. Oh, got it.
So you need to constantly swapping those, but selection sort, you don't have to sort those, swap those.
'Cause I'm
Selection
just
sort,
swapping.
yeah, you
okay.
choose the largest one and then you put it in place and then that element is already sorted. You don't have to
Got it,
move that element anymore.
Okay, thank you so much.
You're welcome. And then someone asked, doesn't the merge step create a new array and then insert it into new values? I mean, you could do the merge sort in place. Can you do that? Yeah, I'm not sure, but the answer here is the selection sort. But merge sort, you are making a lot of comparisons, and then merge sort is not good for the space complexities. Because you're creating new arrays. So think of it in another way, because swap operation is very costly. So swap essentially is just move one element to another positions, right? So if you are creating new stuff, you're putting merge sort is divide and conquer. So first go all the way down and then I merge up. The process of merge up is, you could think of it kind of like a swap operation, which is pretty costly in this definition. Yeah, I think merge sort is kind of out here. So yeah, I don't think merge sort is like a valid here, because merge sort is creating a new and merge back. Okay, so the pivot in the quicksort. So suppose we are having a sorting array with 8 integers using quicksort, and we have just finished the first partitioning with the array looking like this. So we finished the first partitioning, and we have first statement. Which statement is correct? Okay, think about it 1 minute. Okay, I will close the poll in 5 seconds. Okay, the majority of you get a correct answer, which is A. So let me briefly explain. So the 7 or 9. So the way that you see whether we have already to spot the pivot of the quicksort. So pivot will be in the sorted positions after partitioning. So in this array, you need to spot like whether 2 is in its sorted position, whether 5 is in these sorted positions. And in this case, only 7 and 9 is in this sorted position. So the answer is A. The pivot could be either 7 or 9. Any questions?
So in something like this, we would check like, well, we'd first like write it out like 1, 2, 5, 7, 9, 10, 11, and 12, and check whichever number is in its sorted position, and that's a good pivot.
So this array is under the premises that we have already finished the first partitioning, right? So we are checking that whether, so okay, let's fix
right,
on
okay.
7. Whether the element on the left hand side of the 7 is smaller than 7, and on the right hand side of the 7 is larger than 7.
Right, okay.
And it is correct for both 7 and 9, but not other
Okay.
numbers.
Isn't it also correct for 12? Oh, no, wait, never mind. My bad.
11 is smaller than 12.
Yeah,
So those two
I
numbers should be
realized.
on the left.
Yep, thank you.
Mhm. Okay. Okay, linked list. How linked lists work? Everyone know how linked lists work. So let's go to here. So during exam I'm pretty sure you see something like this. We give you a magic like method and let you to predict what will the output of the function. So think about it, and I will relaunch the poll. This one might take a little bit longer. 3 minutes. Okay, I will close the poll in 5 seconds. Okay, I'm kind of surprised. Yeah, the correct answer is D. A lot of you get correct. I think this is a tricky question, but yeah. I just want to briefly say that I got this question from if you go to a company, this is the interview question that they might give you. So it's like after you complete DSC30, and you're kind of in good shape to go to the interview. So yeah, congratulations. So let's go over it together. So you see the magic method. So first of all, this is the base case, right? So if current node is equals to null, we just return, we do nothing. And then we kind of do the traversal thing. So if current.next equals to null, not equals to null, we recursively go to by 2 steps. So 1, 2, 3, 4, 5, and 6. So so first of all, the first node is getting visited, right? The head is getting printed out. So in the console, I draw a console here. It will first print out 1, and then it will call the magic function again. But right now we are here, but we are doing current next. So we're stepping 2 steps. So we are stepping like here. So in the second recursions of the magic, to pay attention, I'm using another color of pen. I'm using a purple one. So purple one, I also hit this print statement. So I print 3. And then so things is still not the last element. I go to the if statement here again, and I hit the I still step 2 steps forward. So I will use a blue one. Is it too light? Yeah. So I will step 5, and then I read 5, right? So right now here's the question. What is the next number that should be printed? So I'm still in the blue recursion, right? So I should continue executing my program in my blue sections. And then since blue right now is in 5, so I print 5 again. So I finish the 5, and then I go back at 3 at here. In purple, the purple node is in node 3. So I print 3 again. And by the same way, I print 1 again. So the correct answer is D. Any questions?
I got one. So when we get to the first 5 statement and we go into the if, right? So we go if current.next doesn't equal null, right? Which it doesn't. It'll be
4.
magic current.next, right? So it'll be that null one right after 6, right?
Yeah, you are correct.
Right. So then we call the current, or we go back up to current, right? We start the magic function again. And then we go if current equals null, we return, right?
Yeah, and that hits the base case.
Right. And then we work back. Okay, cool. Yeah. I just wanted to make sure it was that process.
Yeah.
Quick question. I'm not sure if this question was literally just asked, but okay, when we get to 5, right? Because okay, so we do if current equals null. Well, we get to 3, and then oh god, okay, I need to think about this a little bit more.
Yeah. It's the whole concept with the recursion and plus the linked list. So
could you please repeat how to get the last 3 number? I was quite confused.
So last 3. So
yeah, how do you So
let me redraw this. So there's 3 recursion call, right? The first is the magic, and it's not. I'm denoting the node, right? So the first is magic 1, right? Is the node 1 is the head, and the second is magic 3, right? And then the magic 5. So within the so the reason why we are printing the 5, 3, 1 in the reverse order is that we hit recursion before the second output, a second print statement. So so if I draw a line here, as this is the number 1 when magic head, and then I hit magic here, right? I immediately go to recurse again. So right now I'm doing here. Does that make sense?
Yeah.
And then I recurse to the node 5. So I use a blue color here. So the 5 is the first to get out of this if statement.
Yeah.
So the 5 is the first to print out this print statement, print out the 5 first.
Yeah.
And then the recursion of the magic 5 is finished. And then the purple line continues.
Oh, okay, makes sense.
And you print 3. And then the most outer one, is that the pink one? Yeah, got print 1. So it's in reverse order.
Okay, Scott, really quickly. Okay, so I understand that we get, okay, so for the first one, we do like node 1. If current dot, we print out 1. If do if current dot next is not null, 2 is not null, boom, we go on to 3. Then we do the same thing with 3 and we get to 5. But the issue that I'm having is that I think, doesn't 5 go along with that, like current dot next thing? Because current dot next for 5 is 6. It's not beyond 6. So shouldn't that if statement be current dot next dot next?
So the current, there is another call, but that call is the base case, so I didn't write it. So there is another magic here. So there is a magic, like the base case is magic no.
Right.
Because if right now, if current equals to 5, current dot next is 6, and current dot next is not, which is the base case.
Right.
And then
we return.
we do nothing.
Right. Okay, so then when we return, that goes back to like, that lets 5 finish because 5 was cut off by the recursion. Then
Yeah.
it lets 3 finish because it was cut off, and then 1 because it was cut off.
Correct.
Got it. Okay, that makes sense.
Yeah. Any questions? Yeah, I just want to repeat, this is kind of the thing you go to the company to interview and they ask you this. So good for you. Good for us. Okay. So let's be a little bit creative here. So if we have a circularly linked list, linked list is used to represent a queue. So we kind of want to have it as a queue. So a single variable P is used to access to the queue. So which node should P pointed toward to, such that the both operation in queue and DQ can be performed in constant time? This is a kind of tricky question. I just wanted to like think about it and I will go over it. Okay, I'll close the poll in 5 seconds. All right. So equal amount of people choose A and C. So this is kind of like a trick question. So first of all, we want to imitate a Q, right? So it's good to remind you the Q. Q U E U. It's the first in, first out, right? First in, last out. Yeah, first in, first out. So the Q is according to the rule of first in, first out. The first person coming to the queue go out the first because that person wait a long time. So so we need to achieve that by have access into both rear and front, right? So think about it. I have a P that I need to access to. How can I quickly access the rear and front and do operation on it? And because this is like a singularly linked list, but it's circular, the practice I should do is use the P to point toward the rear. And then the front, I could say the front. I can access the front by saying P dot next, right? So so that I could perform in Q and DQ in constant time. But specifically how to, let me show you. So if, for example, I want to enqueue, where should I enqueue? In front or in rear?
In this case, shouldn't you enqueue like at the rear? Because you gotta like do it right before the front. Does that make sense?
Yes. So I
Yeah.
should enqueue here, right? I should enqueue in the rear. So the way I should do it is do something like this. I put another element here, and I do P dot next equals to the new node. And then P equals to the new node. And then new, wait, I think we should save a temporary variable. So in those 4 lines, we are trying to enqueue another stuff into the circular linked list. So first of all, I changed this long pointer to here, and then I move the pointer to here to move it back to the front. So that's the 2 pointer I changed. So in order to do that, you might need to save a temporary variable of front because you might lost the front. So, but the core concept here is that because we have a circular linked list, and because we want to construct a queue in an efficient manner, the fact that I could have quick access to the rear and front, if I have the P pointed toward rear, helps me to construct a queue from this singularly linked list. Does that make sense? Any questions?
Yeah, Scott, I had just one question. So when you say that, like, what's it called? We have P point to one of them, right? So wouldn't P dot next be rear?
So we want P to point toward rear. P is a variable.
Right. P is a variable, or is it a
P-
node?
P is not a node. P is a variable.
Oh,
So P is a pointer.
okay. So So if we have it point to rear, is the question just asking like, is it better to work with rear or work with front?
So if I put the P equals to front, the
Mhm.
fact that it's a singularly linked list, if I want to get to the rear, I need to traverse the whole list.
Yeah. No,
Yeah.
I understand like the whole like enqueuing thing and stuff, but it's just I'm not understanding exactly what P itself is. Do you know what I mean? Like, because when you say P dot, what I had thought like that,
Oh, I'm sorry.
you get me? Yeah. Because if P is not a node, then how can we say P dot next? Can we do that with something that's not a node?
So P is pointed toward a node.
Is a point. Oh, okay. So it's like a reference to it. And okay. Okay, got it. Okay.
So the answer is the rear node. Sorry.
Sorry, just a quick question. So the front array is not a dummy node, it's a real node with value.
Yeah. I think so. Yeah. I don't think it matters that much here, but it's just the fact that if I want to have a fast access to rear and front, I need to point at the rear because this is a singularly linked list.
I got one question specifically regarding the DQ process. So, oh, never mind. I answered it. Thank you.
Yeah, the DQ it just pointed toward the next node, just fine. You just just manipulate the pointers. Okay, so the time complexities. 1 minute. So what are the time complexities of finding the 8th elements from the beginnings and 8th elements from the end of the singularly linked list? Let n be the number of nodes in the linked list. You may assume that the n is larger than 8. I will close the poll in 5 seconds. Okay, so let's say I have a singular linked list. So the question is saying that I have a singular linked list. So let's say this is the 8th from the left, and this is the 8th from the from the beginnings. So to get the 8th from the beginning, it's easy. I started from the head, and then to head dot next we time it by 8 times, right? Wait, I think 7 times. So this takes constant time because to find the 8th element from the front is not affected by the number of elements in my singular linked list, because I just need to step 7 steps ahead from the head to get that 8th element, correct? So that's the first one should be linear, it's in constant time. So we get rid of B and D. And then if we want to get the eighth element from the rear, remember we are in a singly linked list. There's no way that we could go back. We cannot go back. We cannot go back. So to get the eighth element from the back, we actually need to go from the head and go point dot next a minus 7 times or 8 times. I'm not sure, but that is involving n ingot, which is take a linear time. So the correct answer is A. So finding the front element is constant time, and from the rear is the linear time. Any questions?
I'm sorry. So if you're going 7 times like to the next pointer, isn't that pretty much a loop?
Yeah, you could do it with a loop.
But then doesn't that mean that that's linear time then?
So for example, for int I equals to 0, I smaller than for example 8, I think 7, I plus plus, and you do head. I'm changing the head, but just to illustrate, head equals to head dot next. You want to dot next 7 times, right? And then this for loop is not associated with the n. So regardless of n, whether the n is 10, 1,000, or a million, I only need to execute this for loop for 7 times. So this for loop is not affected by the length of the singular linked list. So the execution time for this is constant.
So the situation is only related to finding the 8th element, like not nth element?
The 8th elements.
So okay, because okay, I thought it was like we find like we can also find like the 10th or 11th element. Like we'll have to find that. But so this scenario is only for the 8th element, which is why it's constant.
Yes.
Okay.
Yeah. Any other questions?
Oh, Scott, are you gonna go past 8 or are you gonna stay?
I'm not sure. I think I need to go at A. I'm tired. And I have 3 parts, and then I think the third part is the last part, and I don't have much like practice question. It just it all has like a summary or review material on that. So I think the last part you could go over it by yourself, and I will release the answer afterward. Just after the meeting, immediately. I'll do that. Okay. But I think like the first 2 midterms, like the first week 1 to week 7 is kind of like far away. So I spend a lot of time to like recap, because that knowledge or that things will pop up in the final exams. And I think that's pretty important. So, okay, I think this part is the last part of the part 2. So let's talk about trees and binary tree and binary search tree. So, yeah, so I think tree traversal, we have 3 traversal algorithms: in order traversal, pre-order traversal, and post-order traversal. And in code, sorry, they're using the idea of, give me 1 second. They're using the idea of recursion, and then they're visiting the node and like visiting the node in different orders to achieve that different traversals. So for now, I'm pretty sure you're kind of familiar with it. We finished the worksheet. So let's do some high level like conceptual question together. So for the first, complexities. What is the worst case complexity for search, insert, and delete operation in general for binary search tree? So pay attention to the wording here. I'm saying in general. So it's not the best case, or you could think of it as a worst case. Excuse me, 1 minute.
Scott, can you repeat what you meant by in general?
Yeah, it means you could think of it as a worst case or average case. Yeah.
Okay, just the average case. Okay.
Okay, I think the wording here, I might like mislead some of you a little bit. So the question is asking the worst case time complexity. In a general binary search tree, it's like it's just a binary search tree. It's not the average time complexity. It's just the worst time complexities. So the general means here, I think it's just saying that it is a binary search tree without any other like modifications, because there is another like set of self-balancing binary search tree like a KD tree or a red-black tree, but that's beyond the scope of this class. So the worst time complexity is log n. Sorry, the linear time for R. So when is the worst case for a binary search tree? When the tree is extremely skewed. For example, I have a tree like this. I don't necessarily have fill-in numbers in this. So this data structure, we're not thinking it as like a tree, right? We more or less think of it like a linked list. So in this case, we're give me 1 second. Yeah, this is like a worst case for a binary search tree. This is essentially like a linked list. So it's like a linear worst time complexity for R. So insertion, you need to insert recurse all the way back to the bottom to find an available spot for the insertion. Deletion, you need to do a linear search for every single node to find the target that you need to delete. And then search operation, yeah, you need to do the linear search. So it's like we haven't spread the tree out. So the worst time complexity for a binary search tree, the cases is extremely skewed. So yeah, any questions?
Will there be wordings like that in the test, like in a general and stuff like that? Because yeah, go ahead.
I don't think so. Yeah, this one is a general binary search tree is like specifying that a binary search tree is in vanilla without any modification.
Okay.
And well, if you have any question, I will be proctoring tomorrow, so you could ask us.
Okay, sounds good. Thanks.
Okay, so I have 3 true and false questions. So this is a high level concept for the post order, post order, pre-order, and traversals and in order traversals. So 2 minutes. Sorry. Okay, I will close the poll in 5 seconds. Okay, so the first question. So in pre-order traversal, the root node will always be the last element being visited or printed. So a lot of people are saying that is true. The correct answer is true. So let me actually copy and paste the traversal algorithm here. Copy. I could just paste it here. So in post-order traversal, right, we see that this print statement is on the last of the recursion call. So the root node is actually the last element to be finished or to be visited in the post-order traversal. So the root node will always be the last element visited or printed. And then for the second question, in pre-order traversal, so the pre-order traversal, the root node will always be the middle element visited or printed. So in pre-order traversal, the root node is actually the first element being visited, right? Because whenever you call the first call of the traversal algorithm, it hit the parent, the root node first, and then you print out immediately without being cut off by another recursion call. So the root node is the first being visited. Now let me move this screenshot down. So in order traversal, the root node will always be the middle element visited or printed in the all visited sequence. So that's a little bit debatable. And the answer of this is false. It might be a little bit like confusing in the first place, right? The in order traversal is printing elements in the middle, but the root node might not always be the middle element printed. So it's the opposite is not true. So for example, we take an example like first of all, like let's say we have a tree like 50. So in this case, the in order traversal will print 21st, 25, 27, and then 50. And then 70, 75, and 90. So in this case, the root node is indeed the middle element being visited, right? But there's another case. So how about I only have a tree like this? So the visited sequence will only be 20, 25, 27, and 50. So the root node is no longer the middle element visited. So this statement is false. So let's prove it. Let's think about it in reverse order. So in order traversal, I'm printing out the element in the binary search tree in the sorted order, right? I'm printing from the smallest element all the way to the largest element. If I have a balanced, perfectly balanced binary search tree, that means that the number of nodes from the left branch of the root node, like right now, the left branch has 3 nodes, right? The right branch has 0 nodes. Therefore, in order traversals, there are 3 elements being printed out on the left-hand side and 0 element being printed out on the right-hand side. So this statement is false. It's not always true. The middle element got visited. Well, the root node will not always be the middle element, but it will be the middle element if I have a complete balanced tree. Any questions for those 3 true and false questions? Okay, good. So how many distinct BST can be constructed with 3 distinct key? For example, 1, 2, 3. One minute, maybe longer. We'll see. Okay, I'll close the poll right now. Okay, so if the number is small, we could just really just try it out and counted how many possible things we could create. So let's decide the root first. So let's say the first situation, 1 as root. So 1. So the fact that it's a binary search tree limited the possible sequence, right? Both 2 and 3 are larger than 1, so I must go to the right hand side. So either I can be 2 or 3, or 1, 3, and then 2. And then if we choose 2 as root, 2, there's only one possible configuration if we choose 2 as the root, right? Because 1 is less than 2 and 3 is larger than 2. There is only one possible way I could do it. And then if we set 3 as root, it's basically the mirror version of 1 as root, because 2 and 1 are both smaller than 3. So I could do this, or 3, 1, and then 2. So there are a total of 5 possible combinations of BST I could create with 3 distinct keys. So the answer is B. Any questions?
Is there like a math formula like for this, or is it kind of just think about all the different cases?
There is one, but I don't remember the formula. It's like too complicated. It involves combinatorics and like, yeah, in exam we won't ask you like how many binary search you could construct with like 1,000 distinct keys. No, definitely no. Yeah, I include this practice here just like a prompt you to think about some property of the binary search tree, because there's constraint on how you could create one. the 3, 2, 1 work? I don't think. Wait, like how many? The correct answer is 5, and so 3 times 2 times 1 is when you have 3 available spot. Like I have a array size of 3. How many combination I could put thing into here? But as a binary search tree, we have constraint. It's a little bit different. Yeah. No, it's you could Google it. It's like from 2n c whatever divided by 4, something like that. I forgot. Yeah, it's a little bit complicated, but that's beyond the scope. It's not that necessary. Okay, the last question of today's. 3 hours. Yeah, I'm still surprised I could speak like 3 hours straight. But yeah, here I am. So a binary search tree is used to locate number 43. So which of one of the following probe sequence is not possible? 1 minute. Okay, I'll close the poll in 5 seconds. Okay, so the question here. So first of all, we have a binary search tree, and we do a query that the target is 43. Excuse me. So which of the one following probe sequence is not possible? Not possible. So a general thing of a binary search tree, the probe sequence is, so we have a binary search tree, right? Each step to the left or to the right is making the assumption that, okay, the number is either larger than 61 or smaller than 61. So we have that promises. So initially, we could think about like 0 to 100. So the first number we probe is 61. Let's say 61 is around here. And because the second number we probe is 52, means that we step the left-hand side of the 61, right? We discard anything that's larger than 61. So we grade this area out. And the second probe is the 52. And we see the third number we have is the 14th. And then 14 is smaller than 52, right? So because 14 is smaller than 52, we discard the right-hand side of the 52. And then we discover 14. Actually, we should compare 14 with 43. And then because 43 is larger than 14, we discard the left-hand side of the 14. And then 17. And we discard the left-hand side. So we have a thing. We started from this wide range, and then we are constantly like shrinking or narrowing our target into our specific like slot. So we need to think about that in that way. So the correct answer is D. D is not possible for this reason. So for example, 17, because the target is 43, I'm assuming that everything I look after is larger than 17, because here's 0, here's 100. 17, I discard the 17, right? And then I go over 77. 77 is smaller, is larger than 43. I discard the right-hand side. And then I do 27. 27 is smaller than 43. So I discard the left-hand side. And then I do 66. And then 66 is larger than 43. So I discard the right-hand side. But here's the problem. For the 18, it's not possible that I encounter 18 again, because 18 has been already discarded. So the probe sequence of D is not possible. Does that make sense? And any questions? Okay. If no, then I think I've speaking up straight 3 hours. You have to listen to me like babbling for like 3 hours. So you're free to go. Okay, one last thing before you go. Actually, this is the end of the quarter. If you think our TAs or tutors have been done a good job, could you please fill out the form of the IA evaluation that you might got an email for? It's like a cake for us. And if you think I'm doing a good job, please fill that form for me. Thank you so much. And then, yeah, I will hand it around like for maybe 10 minutes to answer questions. And yeah.
Yeah. Well, thank you for